All right, we're going to take a step away from parent functions a little bit, and we're just going to consider what is happening for the points of any graph. So we have a random function here, and what we're going to do is purposely use these x values and pick those points out. So when x is negative 5, what is y? 0. When x is negative 4? Negative 2. When x is 0, and when x is 4, and x is 8, and then we have 4. Okay, so these are just ordered pairs on our graph, and we're just going to take a look and see, well, what happens when we do these translations. As a reference, just going back to really quick, we're kind of using this whole idea here where, you know, the x won't change but the y will, or the x will change and the y won't. That's kind of what we're doing for this particular example. So these translations do go with this graph and do go with this table. So taking a look at this first function, what is the translation? What are we doing? This is up to. Now if you're going up to, which variable is changing? The y. And how is it changing? And what do we do to each y value then? So we're going to add 2 to each y value. Well, if you'll notice, we already have the x values here, right? So all we need to do is add 2 to each of these. So then we end up with 0. Perfect. All right, how's the next one different? So this time we're subtracting 2. So subtract 2 from each y value. And what is the translation of our function? That is down 2. All right, so then we are left with perfect, thanks. Because we're moving down 2. Good. Okay, what is happening? What's the translation here? This is actually right to. What do we kind of want to say, like instinctually? We do want to say left, but you do need to remember for the input, anytime you're changing that x value, you're actually going to be moving in the opposite direction. So if we're moving right to, what are we going to do to the x values of each point? We're actually going to be adding 2. So even though this is x minus 2, for our function to get that shift, yeah, so we need to add 2 to each x value. So we have our x values here. What is our new x going to be? Negative 3, negative 2, 2, 6, and 10. Why do the y's stay the same? Right? We don't have any translation happening to the outside of that function, so the y's the same exact values as we have here. So 0, negative 2, oops, not 3, what would it be? Oh yeah, with 3, 0, 4. I don't know, a little brain fart there. It's fine, it's cool. I'm just recording myself, so I might as well brain fart on the video. It's cool. All right, last one. All right, what's the translation? Left 2, which means what are we doing? Subtract 2. All right, so what do we get for our new points then? And what about the y's? They stay the same. Not in, yeah. All right. For example 3, you guys might actually want to star this one, and the reason I say that is because it is a very simple example. I'm really confident that as we go through this, you guys will have no problem getting the answer correct. Guys, we'll have no problem getting the answer correct. The issue is by the time we get to the test, for some reason, You will read this question, and a large group of you are going to be like, what is that asking? What am I supposed to do? So even though the process is simple when you understand it, and I'm talking to you about it, and you know what's happening, all right, a lot of people forget what the question is asking, and they aren't able to reproduce the same things as you will now. So let's go through and see what all these mean. We have this point here. So up here, we had 1, 2, 3, 4, 5. We had 5 points up here. Everybody see that? We had 5 points here, and we talked about how they moved around and how they shifted. Everybody good with that? But now we only have 1 point. But the process is exactly the same as we just did with these tables here, okay? So what you want to do is you want to identify the translation. What's the translation for this one? Up 1, which means which variable is changing? So y plus 1. So therefore, what our new point is going to be? Negative 3, 9. All right, so very simple, but it's a matter of really understanding, you know, like later on if you get it or not. Translation?
Right, 3.
Which means? Add the 3 to x.
The y stays the same.
And the y stays the same. Perfect. So this is going to be 0, 8. All right, I want you guys to try C and D.
Okay.
All right, what do you guys get for C?
Negative 3, 1.
And what do you get for D?
Negative 9, 8.
All right, any questions about this example? No? Okay, so the next one, we're kind of going the other direction. For the next one, they're going to give us the function, and we get to write the equation. All right, so we need to kind of look back and consider like what happens to our function, like for any function if we're going left and right. What happens to any function if we're going up and down? Like where do those values go? Are we adding? Are we subtracting? So if we're going left 7 units, is that the input or the output of the function? That is the left. Is that the x or y? Is that input or output? Yeah, that's the x. So that's our input. That's going inside the function. Now, if our parent function is x cubed and we need an inside, we're going to have a parentheses in there. So here's my input that's changing. And what's going to go on the inside? It'll actually be plus, because to go left, we know the input is opposite that value. Make sense? Okay. Is this the input or output? That's the output. So that means our parent function stays the same. And then how do we show that we're translating up 3? Plus 3. All right, everybody try C and D. All right, what did you guys get for C? What was it? X minus 4 quantity cubed. And for D? X cubed minus 5.